So, hello everyone. Today we are going to solve today's daily LeetCode problem. So let's see what is here. In today's problem, the problem number 3488, closest equal element queries. Okay. So what the problem statement says, you are given a circular array nums and an array queries. For each query I, you have to find the following: the minimum distance between the element at index queries and any other index j in circular array where nums j equal to nums of queries of I. If no such index exists, the answer for that queries would be -1. Return an array answer for the okay. So basically previously we have solved the easy version of this where we are given only one start index and one target element, and we have to find like how many distance we should move in the circular array in either of the direction to reach to the target element. And here the medium, like little bit harder version of it, where it is given some indices and we have to find for that particular indices like how much we should move in either left or right direction in that circular array so that we encounter a same element. Okay, so if we go to solve like this in brute force way, like for every indices I in the queries, we just use the previous method and find it. It will take like linear time for each query, and the query size is also much higher, like 10 to the power 5, and the nums length can also go up to 10 to the power 5. So the time complexity will be q cross n, which is nearly about 10 to the power 10, which will give us TLE. So let's think what we can do here. Like whenever we find any queries, like either we have to use any advanced data structure or we have to do some pre-computation on it so that we can reduce the time. So we are going to pre-compute here. So what we are going to pre-compute for every element, we are going to pre-compute the answer for it, and lastly we will just return the answer for every query. So what is the idea here? So idea is basically very simple. Like let's say this array 1 3 1 4 1 3 2. So let's write this 1 3 1 4 1 3 1 4 1 3 2. Now for this particular, like for what we are going to do, for every element we are going to pre-compute that what will be the answer for this particular indices. Like here this is 0 index, 1 index, 2, 3, 4, 5, 6. Okay. So for this one, what is the answer so that we find another one. So there are two choice from here. We can go either to the left direction or right. If we go to the right direction, we will encounter another one after two moves. And if we go to the left, then we will go from here and there. So the distance will be 3. So here for this one, the answer should be 2. Similarly for these 3, if we go to the left direction, sorry, right direction, we will find another 3 at 4 distance. And if we go here, we will found this in 3 distance. So for these 3, the answer will be 3. So there are only two paths. So what we are going to do, for every element, we are going to compute the minimum distance to find the similar element in left direction and right direction, and we will store simply the minimum of it. Okay. So what will be the simple idea for this? So as the array is circular, so for this one, suppose we are going to find that how many distance we have to move in the left direction so that we found another one. So for that, what we are going to do, we have to just uh, go from here and have to come back. So we can make it more simpler by just copying this array. Uh, if we like 1 second, if we wrote another copy here, like 1314 132, as the array is circular, the character is not going to be change anything. Like this is the copy array, the same array of the original one. So what will be the indices here? Indices is after 6, it will be 7, 8, 9, 10, and so on, like 11, 12, and 13. Okay. So for now, if we have to find like how many distance we have to move left, instead of like from the end, what we can do, we just can iterate over the copy array, and we can query like in this original array, or like the left side of it, how sorry, like how much distance the element exists. Like for this one, see, if I use only the original array, from the one we will found it here, like after 3 moves. And similarly, uh, for here, uh, for also from this one, if we go to the left direction, we will found another one in the three distance. So for left side query, like how much distance we have to move in the left side, we will iterate over the copy array, and we will found like how much distance the one exists. Like for this one, how much distance we should have to move left to find another one? It's just simply 2. Similarly, whenever we will move in the copy array, from here we will find another one. So basically, for any particular element, if any element exists in the left side of it, so it should also exist in the copy array, so it won't affect anything. And if it does not exist in the left side of it, then we have to just like rotate, also go from the back and come back. So for that reason, we are going to go in the copy array, and this thing is like acting like that. So this is the original array, and this is the copy array. So what we are going to do, for right query, like how many element, like how much distance we have to move in the right to find another same element, we will just move in the original array, and we'll find out like how much we have to move right. And for left query, like how much distance we have to move left, we will just move in the copy array, and we'll query for this. So how will we do that? For that, we will use a hash map. uh, like here, first we will update the value of this copy array in the hash map. Like from for right query, we have to move right to left, so that we can update the recent value, like recent, like last, wherever we found that element in the hash map. So for 2, we found it like, for 2 we found it in the uh, like index 13 here. Now 3 we have found it in the 12 index, 1 we have found in the 11 index. Similarly 10 we have found in the index 4, 4 4 we have found in index 10, 1 we have found in index 9. So here we will update this 11 to 9. Similarly 3 we have found in 8, and for 9, for 1 we have found in index 9, index 7. Okay, so we have updated this value in the hash map. Now we will traverse in the original array from the backward. Like for 2, we have to query like where we have last seen the 2, that is 13. So we will just simply subtract from 13 to this 6, and we will get the answer 7. Basically, we to find another 2 in the right direction, we have to move 7 step to get that. And here you notice that 2 only exist one time, so we have to move and came back to the same index to find another 2. So in the last, we can also like distinguish like how is that element exist like one time or multiple time, by like how can we distinguish, like if we have to move the size of the array, that mean we have already came back to the same indices, that means the element exists in the array in just one time. And for 3 also, like for 3 the hash map, and after that we will update the hash map, the 2 value will be 6, and for 3 like 8 minus 5, that is 3. So now we will update it. So this is the idea. So for the left thing also, we will first update the hash map in the original array, then we will traverse in the copy array, and we will just check like how much where the previous element exists. So let's jump into the editor and do that. For that, we will just, and one interesting thing that we don't have to make like the copy array. We can just imagine there is a copy array and we use these indices there. Like we can just add the size here, the size is 7. So if we add the size to the each indices, we will get this copy indices. So we are not going to make any copy, but we are just using this idea that there is a copy. So in is nums dot size. Now we will go vector int. Let's name this as like distance, like how many distance we have to move, and initialize it with n because n can be the maximum. So now we'll find the minimum distance we have to, here we will find minimum distance we have to move towards left to find the same element. So for to find query in the left, what we have to do, we have to use unordered, basically HashMap. Let's name this as position. To query in the left, we have to update the values of the original array in the HashMap. Position of nums of I equal to I. We have updated this. And now we will move on the copy array. So how we will do that? Here we will start from n and it will go up to 2n. Or we can just move this way. And in the copy array, what will be the index? The index will be I plus n. So for that, what we can do, like the distance of I will be minimum of distance of I, comma, the indices in the copy array, which is I plus n, minus the indices here, that is position of nums of I. And then we will update the position of nums of I to n plus I. Because we are now, this is basically we are moving in the copy array. So in the copy array, the index will be n plus I to 2n. So here we are just minimizing the value from I plus n minus like last where we have seen that same element. And then we are updating this to this. Now let's clear that. And for the right thing, we will do the same. For int I equal to n minus 1, I greater than 0, I minus minus. Now we will first update the value in the position for the copy array. So position of nums of I equal to n plus I, because we are updating for the copy array. And we will simply query this. Sorry, I minus minus. We will query this. Basically, let's copy. this, and here we have to find minimum distance. We have to move towards right to find the same element. Here we have updated this. Now we will query like distance of I equal to minimum distance of I, comma. Like right now we are in the original array, so we have to just position of nums of I minus I, and we will update the position of nums of I to I. Now we have done the precomputation and we stored the value. So lastly we will just construct the answer. So vector int answer. We will go over all the queries and we will just push back the value there. Push back distance of I, and we will return the distance. And here if any element exists only one time, we have to just return -1. So how will we uh, distinguish that the element only exists one time? So if this distance is n, basically size of the array, that means we are going towards any direction and we are taking n steps, means we are returning back to the same indices. So it will be -1, otherwise answer will be distance of I. So this should work. Let's run out on the samples. So no template for an odd cap, made some typo. I think, okay, unordered map. So we got some wrong answer here. So let's check this, why we have got the wrong. So output is more than expected. Uh, okay. Oh, we should have to return the answer. Let's check this. It passed on the samples. Let's run on the existing test cases, and it got accepted. So this was the basic idea. Uh, if you are a beginner, you can construct, like you can make the copy array and you can do the same. Like in the nums, you are just push back the values and make the size of the nums twice, and copy that element and do the same operation on the nums. It will also return the same thing. What is the time complexity here? So for finding this thing, we are just traversing over like two times on the array. So it is 2n, and for this also we are traversing on this. This is 2n. So time complexity is 4n, which is linear, which is equal to n linear time complexity. So this unordered map can, in the worst case, it can go n square, but you can use HashMap vector also for that thing to make sure it always run in linear time complexity. So that's all for today. Thank you.